In this video, we're going to take a look at a few examples of comparing polynomials. So number 1 says, which polynomial function has a greater degree? The first option is a polynomial function b of x with 2 absolute minimums and 1 relative maximum. So visually, it would look like a W because you would have 2 absolute minimums and 1 relative maximum. And so these are your minimums, and they're absolute because there's no other point on your graph lower than those. And then you had a relative maximum point. So this function would be a quartic function because it looks kind of like a W, and it had 1, 2, 3 turns in the graph. So it is quartic. So it has a degree of 4, in other words. And for the function they gave us, it says -2 times 3 minus x squared times x minus 4 plus 9. Now there's a trick to figuring out the degree without having to do a lot of work. So what you can do is think of x squared times x, because that's where your degree would come from. And that's going to give you x cubed. And so the highest degree of that function is going to be 3. So don't worry about multiplying everything together. You can tell just by multiplying your x's together that the highest exponent possible would be a 3. And so when it said which one has a greater degree, you'd want to choose this first one. Now the thing with comparing functions is that each question is unique. So it's really hard to show you every example because they could ask a whole bunch of different things about functions. So like I said, we're just going to go over a few examples to try to get you started on comparing. So number 2 said, which polynomial function has a greater number of real zeros? So real zeros are x-intercepts. So for number 2, let's just type that one in, that first one. So we get x squared minus x minus 6. So how many x-intercepts do we have? We have -2 and 3. So there are 2 real zeros for this first one. And that's the only thing we need. We don't need to graph it. We don't need to pick out a vertex. We just needed to know how many real zeros that it had. And by looking at this table over here, we can pick out real zeros because, again, they're x-intercepts. So they are where y would equal 0. So that would be -3. And that would be it. So out of the points they gave us, we can only see that there is 1 real zero over here for this example. And so if we want the greater number of real zeros, we're going to need to go with this first option. Okay, then number 3 says, which function has an odd degree? So looking at the function on the left, it looks like it is a cubic function. So it would definitely be odd. But let's examine the second one. A polynomial function h of x with 2 real zeros and an imaginary 0. So that's a great example to look at. 2 real zeros means it has 2 x-intercepts of some sort. We don't know what they are, but they've told us there are 2 of them. And then it has an imaginary 0. The important thing to remember is imaginary zeros have I. And I will never occur by itself. It'll always be plus or minus something that includes the I. So we know that this problem has to have a minimum of at least 4 zeros because there's 2 real, and imaginary zeros are never by themselves. They're always traveling in pairs. So we would need to go with option 1. So it's odd. It looks like a cubic function, and it has 2 terms. So this one is odd. Okay, so that's just a few examples to hopefully get you started. And just keep in mind that each problem is unique and try to think it through as best you can.